Okay, Mrs. Horner here on our next video, and this next video is on bonding, right? And we've already talked about the two types of bonding, and we're going to focus on the intramolecular bonding here. And if you remember from before, intra is within the molecule, it's between the atoms, and there were two types. Well, water and salt, okay, two common substances, are going to show us the two different types of bonding we're going to see. Now, water, you can see it's made up of two hydrogens and one oxygen. If we were to draw the molecules for oxygen or the atoms for oxygen or the atoms for hydrogen, one hydrogen would have one proton in it, 0 neutrons, because look at the periodic chart and we see hydrogen has one proton, one electron, and 1 minus 1 is 0, so it has 0 neutrons. So we'd have 1, 0, and then, of course, 1 electron floating around in the outskirts on that first energy level. But remember, that first energy level could hold up to 2, but it only has 1, okay? That's hydrogen. And oxygen has like 8 protons and it has 8 neutrons. And again, you figure that out by figuring out the pen. Here's oxygen, 8, 8, and then 15.9 rounds to 16 minus 8 is 8. Okay, 8 protons, 8 neutrons, and then it would have 8 electrons. So we need not 1 because there's 2 in that first one. And then in the second energy level, it would have 6 to make a total of 8. 1, 2, 3, 4, 5, 6, right? So we can see that this one here is kind of missing 1, and this one here is missing 2. Well, look at what happens when water forms. Water forms what we call a covalent bond, right? A covalent bond is going to share electrons, okay? And it has two covalent bonds. It has the oxygen has a covalent bond with this hydrogen here, and you can see the electron from this hydrogen seems to be like kind of in this now, and one of the electrons from the oxygen seems to be in this, and seems to be satisfying that rule of having a full outer shell. Then same thing over here. One electron from the hydrogens here, and one electron from the oxygen is right here. So it's sharing a pair of electrons. This is what we call covalent bonds. Covalent bonds share electrons, okay? And again, all this bonding is going to happen because what atoms are trying to do is trying to satisfy that full outer shell, okay? And there's your covalent bond. All right, now on the flip side, we're going to look at sodium and chlorine. And again, if you drew sodium and chlorine, and I've already drawn them, okay, we know sodium by looking at the periodic chart, 23 minus 11, 12 neutrons, 11 and 11. So they have 11 protons, 11 electrons, and 12 neutrons. Chlorine, right here on the chart, has 17, and then 35 minus 17 is 18. So 17, 17, and 18. Now, when we draw these, we notice, look at sodium. We have 2 in the first shell, 8 in the second shell or second energy level. Shell and energy level are synonymous, right? And then this 1 sticking out there. Now it could have 8 in that shell. It has 1. Is it going to be easier to give up 1, or is it going to be easier to try and find 7 to fill it up? Well, let's see what happens, because what salt's going to do is a little different than what water did. Water shared the electrons. This time, salt's going to actually transfer electrons from one atom to the next and set up these like charged particles, okay? And look at chlorine while we're at it. It has 17 electrons, 2 in the first, then 8, and then only 7 out there. So that's 17 electrons. It has 1 empty seat. Well, this is like perfect, okay? Because this 1 electron that's in sodium is going to actually transfer over to here, okay? When that happens, this whole atom kind of gets rid of that outer shell, but this whole atom takes on a +1 charge because it lost a negative. And when you minus a negative, it makes it a positive. Well, this one over here, though, it gained an electron. It gained a negative. It has a -1. Well, these opposites, and we know what opposites do, opposites attract. This attraction that happens between them, that is what we call an ionic bond. Ionic bond. Okay, I'm going to capitalize that. Ionic bond. An ionic bond happened because they transfer electrons, and then we have to put actually a second step to it. Then opposite ions attract. Opposite ions attract. Okay, and there's a way of figuring it out, but again, that's going to be saved for chemistry next year. So the two types of intramolecular bonding are your covalent bonds. Okay, and remember, intra is between atoms, covalent where they share the electrons, and we can see that's where the covalent bond is, right there, and there's also one right there. Okay, but here we only have one ionic bond, and ionic happens because they transfer the electrons, set up these ions, and then those opposite ions attract. Okay, and that's the difference between ionic and covalent intramolecular bonds. Well, what about the intermolecular bonds? The intermoleculars. Okay, first off, the van der Waals forces. Van der Waals, and I'm not going to illustrate these too much. Van der Waals are weak attractions between molecules, right? And it's usually due to the molecule having a charge about it or having an attitude, what I call, okay? Van der Waals, the key word there is weak attractions. They can be easily broken. So substances that have a lot of van der Waals forces could be like your gases, okay, gases, because gases, the molecules don't want to hold together. They're like free to like separate. But they're also, I like to say, your smelly liquids, kind of like alcohol and stuff, okay, or acetone. That's like what's in nail polish remover. You know, girls, like when you have nail polish remover on or something, or you're using it to remove nail polish, it's a smelly liquid. Those molecules are easily escaping because they're only held together by these van der Waals forces. They're weak attractions between the molecules. But the ones that we have to be concerned with more are the hydrogen bonds. And it's funny, I kind of wish they didn't call them bonds. I wish they called intramolecular bonds, these up here, as true bonds, and these, the intermoleculars, as like forces. But they do call these bonds as well, because bonds just connect things, right? Hydrogen bonds are usually a bond that happens between hydrogen and something that has a real negative kind of aura to it, okay? But it's the hydrogen in one molecule. So it's a force/attraction between hydrogen in one molecule to a highly electronegative atom in the next molecule. Now, fortunately for hydrogen bonds, the highly electronegative atom, what does that mean? That's usually either not hydrogen. It's usually fluorine, oxygen, or nitrogen. Fun. Okay, let's have fun with this. Okay. Anyway, if you see hydrogen in a compound such as like water, right? You want to look to see if there's FO or N in it. And so water happens to have that. But what about the molecule methane? It's CH4. It has the hydrogen in it, but the other element is not FO or N. So you're not going to see hydrogen bonds there. Okay, so you want to look for a molecule that has both those criteria. It has hydrogen in it, and then it has either an F, an O, or an N in it. Okay, and then you're going to maybe see these hydrogen bonds. These are going to be more common in liquids, and this is why water is usually a liquid at room temperature. But also, I want to mention it's common in genetic material. Genetic material. Yes, you know what genetic material is. Good old DNA and or RNA. You're going to see hydrogen bonds quite frequently in DNA and RNA, and you're also going to see it in liquids. And we're going to focus on how hydrogen bonds help water maintain like so many characteristics. And that's it for more detail about bonding, okay? We have our intramolecular bonds, which are covalent and are ionic, and we have our intermolecular bonds, which are van der Waals, which are very weak, and hydrogen bonds, which are a little stronger, okay? Obviously, I didn't mention some of the ones that are in solids, because if these are in gases and your smelly liquids and these are in liquids, what's in your solids? That's those others that I mentioned in the video before, these covalent networks and even these ionic. And it's kind of confusing if I mention ionic again. That's something you'll talk about when you get into like chemistry next year. So right now, we just need to know the intras are covalent and ionic, and the inters that we have to be concerned with are van der Waals and hydrogen. So in biology, that's really all that matters when it comes to bonding. And that's it for our bonding video.